the quadratic formula and the discriminant. Now I'm going to put some videos up here in the corner, or some links to videos up here in the corner that I strongly suggest you take a look at to help you remember the quadratic formula. The first thing you should be able to do is to derive the quadratic formula by completing the square. I already created a video for that. Please see the Derive quadratic formula video. These are the steps for solving problems using the quadratic formula. First, the equation needs to be in standard form and set equal to 0. ax squared plus bx plus c equals 0. Then you list your ABCs, literally what is your a, b, and c value. Then you substitute into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Then you solve for x. You need to have the quadratic formula memorized. Whether you can sing the song, do the dance, or know the story, you need to have it memorized. So remember the story. X equals the negative boy who couldn't decide if he wanted to go to the radical party or be a square. He missed out on 4 awesome chicks and was all over at 2 a.m. Now let's do some work. You have 6x squared is equal to negative 5x plus 4. Step 1, put the equation in standard form. That means I'm going to have to move the negative 5x and the 4 to the left-hand side. Now I need to list the ABCs. The A value is equal to 6, the B value is equal to 5, and the C value is equal to negative 4. Now all you do is substitute into the quadratic formula. Remember that's negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm just going to substitute the values in. I have negative 5 plus or minus the square root 5 squared minus 4 times 6 times negative 4. All over, and this is key, make sure your division symbol goes all the way across, 2 times 6. Notice wherever I substituted, I used parentheses. Now we simplify the equation and solve for x. You should have gotten negative 5 plus or minus the square root of 25 plus 96 over 12. Which then simplifies to the square root of 121, still all over 12. At this point, you separate into two equations, the positive and the negative, and then continue simplifying. Gives you a final answer of x equals 1/2 or negative 4/3. Remember, read the instructions as to how they want you to write it. We might want an or, they might want a comma, or they might want it in point notation. Point notation, the y value is always 0. Make sure you're reading the instructions to see how they want you to answer the problem. In this problem, we have a y plus 21 on the wrong side here. We need it in standard form. I'm going to subtract the 21 to the other side, which gives me y is equal to 21x squared minus x minus 21. Now remember, whenever I'm solving for x, that means I'm using the intercepts, which means the y value is 0. So we can simply get rid of the y because the y value will always be 0. Now I list my ABCs. Make sure you pay attention to the negative signs. That's where most people make mistakes. Now I can plug it into my quadratic formula. So I have a negative, negative 1. Again, this is why we're using parentheses, so that it's obvious that you have two negatives. Negative 1 squared. The parentheses remind me to square that negative, making it a positive. And again, I have the parentheses here showing that it's multiplication, not subtraction. And again, we'll have a positive inside. Now we simplify these. Negative times negative is a positive. Negative 1 squared is a positive 1. Gives me plus 168 on the inside. Continue to simplify. Once you're at a point where you can take the square root, then you're going to split it into two equations. gives you x is equal to 1 plus or minus the square root of 69 was 13 all over 4, and then just continue to simplify. X is equal to 7 over 2 or negative 3. Now this problem is weird looking, but it's no different than any others. They want us to solve using the quadratic formula. The first thing I would do is say, hey, it looks different. Is there any other way, faster, easier way to solving it? And the answer is no, there's not. So I'm going to follow the directions and solve using the quadratic formula. In order to do that, I first need to distribute and then set it equal to 0. That gives me 10x squared minus 2x minus 9 is equal to 0. Now we list our ABCs and plug them into the quadratic formula. Once you have them all substituted, pay attention. Negative times a negative is going to give you a positive 2, and then negative 2 squared is a positive 4. And then go ahead and simplify these. That should give you something about 2 plus or minus the square root of 4 plus 360 divided by 20, and then you can continue to simplify inside by adding the 4. At this point, we can simplify the radical, which means we're going to split it into a positive and negative. In order to simplify the radical, do that as a side problem. Square root of 364. Now it's easiest if you have a calculator that'll simplify this for you, but if not, you can go by 2's, 4's, or any other number you think will work. I know that a 4 will go in, so I use my calculator and figure out that 4 goes into 364 91 times. Well, 4 breaks into a pair of 2's. I know the pair of 2's can come out. 91, we can try different numbers. I know it's not divisible by anything even because the 1, 9 plus 1 is 10, so it's not divisible by 3, 6, or 9, so it really isn't divisible by anything. So the 91 is left inside the house. That's going to give me a positive and negative version of 2 plus or minus the 2 square root of 91 over 20. The 2 on the outside was able to come out of this 364. Now I can still reduce this. Notice that there's a 2 in front of both. Technically, what I'll be doing is saying 2 minus 2 square root of 91 and then taking out GCF. 2 parenthesis 1 minus the square root of 91. And that's how I'll be able to reduce from top to bottom, which is going to give me x is equal to plus and minus the square root of 91, and that's all going to be over 10. Remember, because there was 2 2's on top, I was able to reduce by a 2 with the 10. Alright, again, this one looks small. It's actually pretty simple. First step is going to be getting the 5 to the other side, and then write your ABCs. This is usually where people mess up on this one. The A value is 3. The B value, well, remember, B is supposed to go in front of the X. There is no X term here, so I simply have a 0. And then the C value is negative 5, which gives me, that's going to give you X is equal to plus or minus the square root of 60 over 6. And we can simplify that 60 as a side problem. The 4 breaks into a pair of 2's, and the 2's can come out, which gives us positive and negative versions of 2 square root of 15. I can reduce the 2 and the 6, so the 2 cancel out and become a 1. The 6 is going to cancel out and become a 3. Now, if anybody is tempted to reduce the 15 and the 3, I hope that you stopped yourself, because the 15 is inside the radical, the 3 is outside the radical. They cannot talk. One's inside the house and the other's outside the house. Yes, there is a faster way of doing this. I was showing you how to use the quadratic formula and where a lot of people make mistakes with that 0 term. The faster, easier way of doing it would have been to do this. X is equal to the square root of 5 over the square root of 3. Now, if you don't know about rationalizing denominators, this is why you would get it wrong, and you should have used the quadratic formula. If you do know how to rationalize your denominator, then you'll be good. So, if you know how to rationalize your denominator, you get the same answer a lot faster. However, if you're not sure about that, then use the quadratic formula. The quadratic formula will always give you the correct answer. Moving on to the discriminant. What is the discriminant? It's the inside of your quadratic formula, just the b squared minus 4ac. That's all it is. Why do we care? Well, if you're only looking for real solutions, then you don't want to go through all of the work to figure out that there are no real solutions. When you plug it in, if the discriminant is negative, you're going to have no real solutions. You will have complex or imaginary numbers, complex solutions, and we'll cover those later on. If you have a discriminant of 0, then you're going to have one real solution. And so that's going to look like this. You're just touching the graph one time. Now, if the discriminant is positive, you're going to have two real solutions. So the previous examples all would have had positive discriminants, meaning you're going to touch the x-axis twice, giving you two solutions. This is what it's going to look like. The steps are similar. First, we need the ax squared plus bx plus c equal to 0. We need it in standard form. So on this problem, I need to subtract that 12x to the other side. Now I just label my ABCs and then substitute into the discriminant. So I don't need the whole quadratic formula. I just need that little piece in the middle. When you substitute, you get negative 12 squared minus 4 times 1 times 36. Then simplify. My discriminant is 0. I had 144 take away 144. What that means is that I'm going to have one real solution. So a lot of problems will ask you for both the discriminant and how many solutions you have. We can always check our answer, and we are correct. One distinct real solution. Here's another one. Let's follow the same steps. Subtract the 12x to the other side, giving you, now list your ABCs, and then plug it into the discriminant, which gives you negative 12 squared minus 4 times 1 times 40. 144 take away 160 is negative 16. So our discriminant is negative 16. You're going to see the answer to that written two ways. One way is going to be no real solutions. If you're only dealing with real numbers, then you're going to have no real solutions. If you're also working with complex numbers, then you'll have an answer of two distinct non-real solutions. So later on, when we're dealing with imaginary numbers and complex numbers, we will say we have two non-real solutions. Right now, however, we will have no real solutions. Last problem, again, subtracting that 12x to the other side. List your ABCs. And then plug it into the discriminant, which gives you negative 12 squared minus 4 times 1 times 30. Your discriminant is 24, which means it's a positive number, so I have two real solutions. And we can always check our answer.